Okay, this is the fall final review, and I'm going to start with question number 11. So 1 through 10 is on a different video. So for question number 11, what we want to do is we want to graph our piecewise function. So I'm going to look at this as two different equations. So I'm going to start with the top equation, so which is this one right here. So that would be y is equal to 2. And then this will not have a start or a stretch because the equation is a special case, right? There's not an x and a y. So then I just go to where y is equal to 2. And then it's a horizontal line, so y equals 2. And then for my split point, I look at where they want to break off the graph, which is at 0. And so when x is 0, normally I would replace the x over here with 0 and simplify. But in this case, there's not an x to use. So that means that the y value will be always 2 regardless of x. And then I'm going to use an open dot because there's not an equals under this, right? So it's not equal to, so then I need to use an open dot. So I'm going to go to 0, 2. So over 0 up 2, and I'm going to put an open dot. And then I'm going to highlight the portion of the graph that would be less than 0. So from my split point, so from here, I either need to trace the graph to the left or trace it to the right. And so because I want to be less than 0, I need to go towards the left. So I'm going to highlight this section of the graph. So that's the piece of the graph that I want to keep. And so then I don't need anything else, and so I don't need any of this part here. Okay. So now I want to do the bottom equation. So this equation right here. And so the 2 does not belong to the x, because if it did, it would be in parentheses. So I'm just going to subtract the 2 to the other side. So all I did was subtract the 2. And then put a negative in front of the x, so negative 1x. So I'm just minusing the 2 over because it does not belong to the x. If it did, it would be grouped with it. So then my start point, I want to go in alphabetical order, so I'm not adding anything to the x, so that would be 0. And then here I'm subtracting 2, so I always want to do opposite, so that would be at 0, 2. So I'm going to go to 0, 2, which is right here. And then my stretch is negative 1. So from here I'm going to go down 1 over 1. And so for this graph here, this is linear because it's not squared. There's no absolute values. So then I'm going to go up 1 and left 1 for the symmetry, and then I'm going to extend it in both directions. And then I want to find my split point. So my split point is starting at 0, right? I'm looking to see where they want to separate the graph, so that would be at 0. And then I want to evaluate my equation at 0, so I'm going to put 0 in for x. So I'm just going to do that right here. So I have negative, replace x with 0, and then plus 2. So 0 is not positive or negative, or if you want to think of it as negative 1 times 0, that's just 0. And then 0 plus 2 is 2. So when x was 0, my y value is 2. So my split point is at my start, which is at 0, 2. And then because it has a line underneath it, that means it can be equal, so I'm going to close in the dot. So even though it started out open, I do need to fill it in because the second point is solid inclusive, so then I'm going to close in that dot. So then I'm going to start from the split, and I have to see which way I want to highlight. Do I want to highlight going up and to the left from my split or down and to the right? So here it says x is greater than or equal to 0. So for some of you may be thinking, oh, I need to go up. But remember, if it's x is greater than or equal to 0, that's towards the right. So how do I go and get towards the right? If I trace this graph going up, will that get me towards the right? No. I need to go towards the right, so I need to go down and to the right. Okay. And then the piece of the graph I don't need is this over here. Okay, so there's the graph for number 11. Okay, so let's go ahead and take a look at question number 12. So I'm going to do this in the same fashion. I'm going to take a look at the top equation separate from the bottom. So I have y equals and then x minus 1 squared. So my start point, I'm going to go in alphabetical order. So x before y. So I have x minus 1, so that will be positive 1. And then I'm not adding anything to the y value, so that would be 0. And then my stretch is 1, so that's the implied coefficient in front of the x, so my stretch is 1. And then for my split point, so they're separating the graph at 3, so I'm going to let x equal 3. So when I replace 3 into here to find the corresponding y value, so replace x with 3, and then I want to simplify that. So 3 minus 1 is 2, and then 2 squared is 4. So when x was 3, my y value was 4. And then it is not equal, so that means I'm going to use an open dot for that. Okay, so now let's go ahead and graph all of this. So my start was at 1, 0. My stretch is 1, so up 1 over 1. And then it's a quadratic, so I'm going to reflect over to the other side. So up 1 to the left 1. And then my split point was at 3, 4, so I'm going to go ahead and graph that too while I have it. And then it's an open dot. Okay, and then let's go ahead and graph that. So then I want to highlight the section of the graph that is given by this direction here. So I start always at my split point, so I'm going to start at my split point, and then I need to decide how do I trace the graph so that my x values are going to stay less than 3. So do I trace from the split point going down to catch the vertex, or do I just go off and up to the right? So if I want to go to smaller values of 3, then that means I need to go to the left. So I want to head towards the left, and so that means I'm going to trace the graph going down and then right back up. But I'm always staying to the left of that open dot, right? No matter where I am on this section that is pink, all of that is staying to the left of the open dot, and so then I don't need any part of this. So then let's go ahead and do the bottom equation as well. And so here I'm going to add the 1 over to the y because it's not grouped in with the x. So then that would be y plus 1 is equal to the absolute value of x. So if it was grouped like up here, then it would stay with the x, but it's not, so it belongs to the y. So then my start point, I want to do alphabetical order, x before y. So here I'm not adding anything to the x value, so I can always use 0. And then I'm adding 1 to the y, but I want to do opposite, so that would be negative 1. And then my stretch is the number in front of x, so there's an implied 1 here, so my stretch would be 1. And then I want to find my split point as well. So again, the x is 3, so I'm looking up here, so they want to separate the graph at 3, and then I have to find the corresponding y value, so I have to replace this x with 3. So I'm going to replace that x with 3, and I'm going to squeeze it in over here. So then that would be the absolute value of 3 minus 1, and then that's just 3, minus 1 is 2. So when x was 3, I got an answer of 2. So, and then that's going to be an open dot as well because there's no line underneath the inequality. So let's go ahead and graph it. So I go to 0, negative 1, and then I have a stretch of 1, so up 1 over 1. And then this is an absolute value graph, so then I'm going to reflect it to the other side and go up 1, left 1. And then I have a split point at 3, 2, so open dot right there. And so my whole graph is going to look something like that. Okay. So I'm going to start at my split point. I'm going to make that an open circle, and then I have to figure out which way I'm going to trace this graph. So I want to trace so that x is greater than 3. So when I trace this graph, if I want to stay greater than 3, I need to go off to the right, right? Going towards the right. So if I want to go towards the right, that's going to be just this little section right here. And then none of this part, right? So I'm going to erase that like that. Okay, and then that would be my graph for number 12. Okay, so now let's take a look at question number 13. So for question number 13, they're just making sure that you know how to identify pieces of the graph and that you know their appropriate name. So our choices are, do we have a linear graph? Do we have a quadratic, an exponential, or linear absolute value? So from here, it says this is an open interval, so open meaning parentheses, and an interval means we're doing left comma right, and we're specifically talking about values of x, right, values of x. So when they're writing -4, 1, they do not mean the ordered pair -4, 1. They mean look on the graph from -4 until you get to 1 on the x, right? So they're looking between -4 and 1. That's what they're meaning here. So if I look at the graph from -4 to +1, so the graph that's there is this one right here. And so that's just a line. So then this would be linear. So for part B, so again it says look on the open interval, so left comma right, so from 1 to 3, so here's 1 and there's 3. And if I look between those 2 points and I look at this shape right here, this is a curve that's symmetrical, so then that is going to be a quadratic. And then on this section here, so if I go from 3 to 9, so from 3 to 9, so if I look in between 3 and 9, I have this graph right here. And that's a negative linear absolute value, but I only need to write that it's a linear absolute value. Okay. And then lastly, they want me to go between 3 and 5, so between 3 and 5, so only that piece there. So when I only see part of that absolute value, so one branch of it, then that means it's really a linear function that we have, not an absolute value. So even though the whole graph is a linear absolute value, if I look at just one section of it, that's only going to be linear. Okay. All right, and then let's take a look at the other pieces here. Okay, so for question number 14, they want me to state the open intervals on which f is increasing. So when I talk about a function increasing, I want to know, where is it going uphill essentially, right? When is it going uphill? And when I do that, I have to go from left to right. So as I trace this graph right here, I'm staying constant. And then now I'm going downhill, so that would be decreasing. And then now I'm going uphill, so that's increasing. So then this section right here, I'm increasing, right? I'm going uphill there. Let me actually use a highlighter. So I'm going uphill on this section right here. And then I'm still going uphill, just on a different part of the graph. So I'm going uphill on this section right here. And then I go downhill after that. So the only piece I'm increasing is the part that's highlighted. And so when I do my open interval, I want to do left comma right. So left comma right. So if I look at the graph, the farthest left the highlighted section goes is to 2. The farthest right the graph goes is to here. So I want to know how far right is that. So I can just kind of count. So 1, 2, 3, 4, 5, right? So the farthest right it goes to is 5. So between 2 and 5, I have the highlighted portion, and then open meaning parentheses. All right, so now for question 15, they're asking, where am I decreasing? So when I'm decreasing, that's when I'm going downhill. So the sections I'm going downhill, so I'm constant here, but over here I'm going downhill. And then the other part I'm going downhill is right here. So I have 2 different pieces where I'm going downhill, so I need to create 2 different intervals for that. So I'm going to do the first highlighted section here. So for this piece, I'm going downhill, so left comma right. So between 1 and 2. So on the x-axis, between 1 and 2 is my highlighted portion, which is where I'm decreasing. And then open, meaning I use parentheses. And then union, meaning there's another interval. So if I look here, on this highlighted portion, I'm going down, decreasing between 5 and 9. So then I'm on the x-axis, between 5 and 9 is where I'm decreasing. Okay. All right, so now for domain and range. Okay, so for domain and range, I want to fill out my 4 corners. So the first thing I should always look for is arrows, and I don't have any arrows, so that means I have to actually count to find the different values. So I'm going to just start with the up, so I want to look for the highest point on my graph, which is right here, and I want to see how high up that goes. So if I look, that goes up to 1, 2, 3. So this graph goes up to 3, so there's my up corner. And then I want to see how far right it goes. So this is the farthest right, and it goes out to 9. And then I want to see how far down my graph goes. So the lowest point I see on my graph is right here, and that's on the x-axis, so that would be at 0, so it doesn't go down below 0. And then my farthest left point I see is this one right here, and the farthest left that goes is to -4. So then for my domain, I do left, comma, right. And then they are both closed dots, so then I'm going to use brackets on those. And then for range, my range is bottom, comma, top, so the bottom is 0, and then the top is 3, so bottom, comma, top. All right, and then question number 18, they're asking for a maximum. So a relative maximum is when we change from increasing to decreasing. So when the graph changes from increasing to decreasing, and I need to write that ordered pair, which is x, comma, y. So this is usually very confusing for students because up till now we've been doing 2 values of x, right, for open intervals. But now all of a sudden we're switching gears and I want an ordered pair, so I want an x and a y value. So when I'm looking on the graph, I'm looking to see where do I go from increasing to decreasing, and that would be at this point. So this is a specific point, so I need to come up with its x and its y value. So that ordered pair is at the x equals 5 and the y equals 3. So this is an ordered pair x comma y, whereas everything up here though was not, right? These were both values of x. And then question number 17 is asking me to find a relative minimum. And then a relative minimum is when we switch from decreasing to increasing. And again, we want an ordered pair x comma y. So I'm going to look on the graph from where I switch from decreasing to increasing. So let me zoom out just a little bit. So if I look at this graph, I'm going from decreasing to increasing on this little section right here. So specifically though, right here. So that is my relative minimum because that's the point of transition between decreasing and increasing. So I need an ordered pair for that, and that's at x equals 2 and then y equals 0. Okay. All right, and then let's go ahead and now we have to write a 3-piece function. And so I'm doing this just like I did on the front side. I need to write equations for each of these points. Okay, so I'm going to put my final answer off to the side over here though. Okay. So I have 3 equations I have to write. I have to write one for this line, but this one's easy because that's a special case, right? It crosses the y-axis at 2, and it does that between -4 and 1. So between -4 and 1, y is equal to 2. And so now for this one right here, this is a quadratic, so I want to find my start point and figure out what my stretch is. So for this one in particular, so my start point is the vertex, which is right here. So that would be at 2, 0, so that's my h and my k. And then for my stretch, I can actually count this one because it's only going over 1. So for my stretch, I'm going up 2 over 1, so up 2 over 1. So then my stretch would be 1. Okay. So again, my start point is at 2, 0, and then my stretch is, how about a 2 there? So up 2 over 1, so my stretch would be 2. So the basic equation of a quadratic looked like this. So that's a formula we have to get memorized, right? So I'm going to replace my h and my k. So my k value is 0, and my a is 2, and my h is 2. Okay. And then y minus 0, I don't need that y value. I need like 2 minutes. Okay. And so then I only need to put this part over here. And then for my parabola, it's in between 1 and 3. So if I look here, it's between 1 and 3. And so I already closed off 1, so I don't want to include it again. And then I'm going to close off the 3. So even though it's a closed dot on 1, I'm using a parentheses because I already included it there. Okay. All right, and then the last one here. So this is linear absolute value. So my start point is at the vertex, which is at 5, 3. So that would be h and k. And let me write that equation out. And then for my stretch, let's see if I can count that here. So for my stretch, I'm going to go down 1, 2, so down 2, and then over 1, 2, 3, 4, over 4. So then my stretch will be down 2 over 4, or I can reduce that to -1/2. All right, so then my equation, so I want to replace k, so that would be y minus k, which is 3, and then my stretch was -1/2, and then x minus h, which is 5. So I need to get y by itself, so I'm going to add 3 over to the other side, and so then y equals -1/2, x minus 5 plus 3. And so then that equation goes here. And then for my interval, my absolute value graph is between x equals 3 and x equals 9. So between 3 and 9 is my linear absolute value. And the same thing here. So I have closed on this one, so I don't need to, oops, you guys can't see that. So I have closed on this one, and so I don't need to close on that one as well. Okay, and that's it for this portion.